An isotope of potassium with 42 neutrons and protons. So we can go across here and we'll see that whatever it is going to have the same number on the top.
Right.
Okay? So we need to know the atomic number of potassium. And for that you would go to your handy dandy periodic table.
Yeah, if I can find
I will look.
Thank God there's one for me.
19 is not the one, right?
I actually don't know.
It's,
Does it tell me?
it is 19.
It is 19.
Okay, 19. So, 19.
And then 18.
So this has to be 20, because 20 minus 1 is 19.
Right.
And we're turning a neutron into a proton, so we have to increase this number. So what comes after potassium?
Calcium.
Calcium. There you go. And you're done.
Can we do this with another one?
Yeah. Capiche?
Yes.
O capito? Yes. 239 Pu
It smells.
goes to 42He plus something. And what kind of decay is this?
Nuclear?
What is this? It's another word for this.
Alpha.
Alpha particle.
Alpha.
Oh, yeah.
Awesome. So, plutonium emits an alpha particle. So, how much does this number have to drop by?
4.
4. It's not that bad, right?
So it becomes 235.
It's 235, and what about this number down here?
Okay.
That?
You take away 2.
You take away 2, so what number is plutonium?
94.
P. Yuki! Okay. Minus 2,
92.
90, and
And
what
that's
element is that?
uranium.
It's uranium.
It's radium.
Okay,
No.
let's talk about this.
Actually, plutonium is 94 and uranium is 92.
Oh. My bad. And you're done. It's not so bad, right?
Nope.
What about this one?
Wait, I have a question for you.
Okay.
Does the bottom number or the top number change the type of element?
Bottom of it.
Okay. Like if that was 94.
So here we have the hydrogen.
It was
And what is this?
Oh, you skipped one.
I know.
Oh, okay.
Yes.
The future.
Close. There's 3 of them. Tritium. This is tritium. Tritium being an isotope of hydrogen. It has 2 neutrons in addition to its proton. And we have regular hydrogen joining with tritium. Yeah.
We were doing number 4 instead of number 3.
What?
No,
Yeah.
she knows. You're doing number 4.
I know. Yes, we do know
Well, you
that.
numbered it 3.
Oh, I numbered it
Numbered
3.
it 3.
Okay, no wonder there was confusion. Okay. So what do we get over here? Yes.
Helium.
Because 3 plus 1 is 4,
Mm-hmm.
and 1 plus 1 is dos, is helium.
Oh, that makes sense.
Now, here's the question. What process is this?
Well, even though it's under nuclear decay equations, it's technically fusion.
Which is also, yeah, you're right, actually.
Then what's
You're right.
fission?
This is fusion. Good.
Fission is splitting.
Fusion is splitting.
Okay.
Fuse, think fuse. Things
Like-
fuse together, they
They come together.
Yeah.
Combine.
Okay.
Should be easy for anyone who's ever played Yu-Gi-Oh.
There you go.
Here, this left.
Bye-bye.
One more.
Can we do fission
Bye,
problem after
Julio.
that?
What?
Can we do fission problem after?
Sure, why not?
Good.
This is number 9. Number 9. Blank plus 10 n.
Oh,
What's
boy.
that? It's a 10 n. What does that mean?
Oh.
Nice.
Thank you. Neutron. It's a lowercase n.
Barium.
Let's say 91. Proton 36 plus 3
Yeah.
neutrons.
Should you combine the neutrons first?
What's that?
First of all, this looks really familiar to me. I've seen this several times. So I already know
Thank
what
you.
goes in that blank.
Alright.
This is nuclear fusion. Nuclear fission.
Where's
It's the process, one of the processes that happens in a nuclear reactor. So let's backtrack. Hang on. Let's start with atomic number. 56 plus 36 is 92. So whatever it is, it's 92. 92 is uranium.
Yep.
This is the classic fission of uranium by an incoming neutron.
Does that become 235?
So what about this? 146 plus 91 plus
1.
2, 3. 3. No, but it's 2 because there's another neutron there on the other side.
So 4.
Oh, you're right.
So it's
Good
not
job.
2.
So it's really only 2.
Why is it
And it adds
only
up
2?
to 3.
Because there's a neutron here.
So does that become 250 then?
Oh, so it loses more.
Yeah. Well, this is fission,
Oh.
so that's part of the whole equation. So we get 146 plus 91
I can do
plus 3 minus 1.
239.
235.
235. So this is the fission of uranium 235.
Oh, we've done this before.
Yes, we have.
Yeah, even I remember this. I remember how to do it.
Do you guys see all the pollen falling from the sky?
Oh, those are the flowers.
So go to the next sheet where it says nuclear chemistry worksheet. This time they're in words. So we have to kind of figure out what the equation is. So for example, number 1,
Should we have been writing the
the
answers
alpha
down?
decay of radon. Oh, this is for your information. It's FYI. Radon 198. Radon is Rn, I believe.
Yep.
So this is saying this. And the alpha decay means that it's giving off an alpha particle or a helium nucleus plus a blank. And then you go through what we did before to figure it out.
So that would be.
Not so bad, eh?
Radon is 86.
It's 86.
So yeah, those.
So we get a 194 here. And an 86 minus 2 is an 82, which is
No, 84. Chem.
Polonium?
polonium.
Wait, why are you subtracting 4 again?
Wait,
Because the helium nucleus is taking
Oh.
off 4 nucleons.
Oh.
Yes.
wouldn't you, wouldn't only go down to 94, not 92? But
Yeah.
are you starting with radon?
It went down to 194. And
Yeah,
this
shouldn't
number
it go
went down
down?
by, oh, whoops,
Yeah, I said that.
That's what I was gonna say.
my bad. 84. Is it 80? Wait.
84 is
Polonium.
polonium.
Yeah, she got it right, but I got it wrong.
Okay.
That's usual.
Yeah.
What's that?
Can we do one more?
Sure.
Go with different elements. Like nickel. Could nickel work?
Nickel?
Nickel.
Nickel is a transition mineral. It's not really.
Yeah. I think that's all I want to do right now, because you get the answers and now you understand how to do it. A positron, the only thing you need to know that positron, I don't think I put that in the vocab, so I didn't give you any positron nuclear decay stuff. So,
There was one.
was there? Yeah, but in the worksheet, but not on the quiz. There won't be any.
Okay.
Positrons.
What is a positron?
It's the antiparticle of an electron.
Why?
Same
would
mass,
that be on
different
the quiz?
charge. What?
Why on earth would that be on the quiz?
Right. Because you can have a positron, a decay by positron machine.
That sounds dangerous.
Yeah.
I don't know what it
It's
is.
not bad.
Yeah, thanks for making this.
Well, out of
So
curiosity,
what are like,
antiparticles and antimatter.
Yes.
what's the antiparticle? The
Yeah.
proton.
The antiproton.
I was just wondering because like positron is like
Yeah,
a
it
different
has a
beginning
nice
than an
name.
electron.
So there's a proton, and the antiproton is symbolized like that.
Mhm.
Then there's an electron, and then the positron.
Mhm.
And there's neutron and antineutron.
What's an anti-neutron? Like does
Yes,
it like
Well,
magically have
protons
a
and
star?
neutrons are made of quarks.
Then you get each other.
And so it would have the complements to those quarks instead of the quarks.
Okay.
And quarks come in different colors.
They're very
Yeah,
quirky.
that's strange.
They're very quirky.
Terrible. I hate it.
Ooh.
And there's neutrinos, and then there's
Pam.
antineutrinos, there's muons
No.
and antimuons, which are
Pam.
positive.
They come in many different, like, the quarks come in many different colors and
Yes,
stuff.
then there's the tau
They're very quirky.
Yes, they are.
That
Then there's an anti-tau.
Do not
All kinds of good particles out there. In fact, there was kind of an explosion of particles.
Well, part of me just died.
And then everybody wondered what was going on because the whole idea was to
Yeah.
find such thing.
Can we go over
The
half-life?
fact that
Oh, that was a good
seeing
one.
more and more
Oh,
kinds
yeah.
of particles was a little bit odd.
Excuse
Pam.
me, Pam?
Yeah,
Yes.
my life
some of the
expectancy just went down
half-life
by a few minutes.
Yeah, I was about to
Oh
say.
yeah, I'd like that too, actually.
Half-life stuff?
Yeah.
All right. Well, the next thing in this is the nuclear reactor.
Oh, like with the fuel rods?
Power plant diagram. Yeah, you rad.
Wait from the Plymouth, please.
You guys have snowballs with 7 balls.
Do I want to draw this or do I want to hook up my? No, I want to draw this. Okay. Yes, I'll draw it.
And then there was.
And then there were none.
And it produces steam, right? When you say produces steam.
Okay. Then we've got another compartment like this. Oh, this is spooky.
Want me to draw?
No. No, I appreciate that.
I use the
Put
rocks
this together.
Yes, you may use your-
Just trying to help. Last time I were off for Pam.
Yeah, duh.
More money, more problems.
Thanks a lot.
No, less money, more problems.
You know I'm kidding, right?
That is the truth.
There's a turbine in here. Goes around in circles. There's a heat exchanger here. There's a generator here. Then there's these funky cooling towers over here. Okay, ready?
Yep.
I'm ready. Let's
Aye, aye, Captain.
identify the parts.
That looks pretty funky.
Containment building.
You
We got
look
the
pretty
containment
funky.
building. We're gonna get raided. Alright, here we go.
What else is new?
Here we go. So, this
This
is
is
the
hurting.
nuclear reactor core, this baby in here. And inside it are
I like that you know how to draw this.
rods.
I said I really like that you know how to draw this, like freehand, like it's out of nowhere.
Well, I was looking at the
She was
paper.
looking at the paper. Oh, alright.
No, I wasn't. I did it at
Are those the control rods?
These are the fuel rods, and then there are these control rods that
Yes.
can go up and down.
Yes.
Yes, I
And
do remember
those.
that. They explained this in the video, correct?
I think they did.
Because I have a memory of it, unless I just kind of...
Fuel rods. And these are where Captain Uranium lives. Now,
What?
Captain Uranium.
I'm sorry, is there no Captain Uranium?
No.
Oh.
No.
Well, there should be.
There's a Captain Radon though.
Sam, what's the superhero in
There's Captain America.
The Simpsons? Adam
Yeah.
something.
Captain America.
Oh, there's not radium.
No,
Radioactive man. Radioactive man
So,
and Fall Out Boy.
The fuel rods are made of uranium, and there's a critical mass of
You can like
fuel.
shrink into a little thing.
Is that where most of the fuel is stored?
Or
Is that where Fall Out Boy got their name? Yeah, that's where Fall
I
Out Boy
think
got
his
their name.
name's literally
Critical
Adam.
Wow.
So critical mass means
Your job.
that fission will proceed undaunted unless something is done about it. So instead, we have these things called control rods that are made out of material that likes to absorb neutrons.